This 2024 paper 1 question 3, we're given this integral. So the integral of cos normally, so the integral of cos of x dx is equal to sine of x plus c. And the reason for that is because when you differentiate sine, you'll get cos. So if we have the integral of cos of 6x dx, it's kind of like the chain rule in differentiation. So we have to differentiate the inside function, but instead of multiplying by the derivative like in the chain rule, we divide by the derivative to get 1 over 6, and then differentiate the outside function, which will be sine of 6x, and we have plus c. And you can check this by differentiating this. So if you differentiate this, you'll do the derivative of the inside, which is 6, and multiply that, and then the derivative of sine is cos, so the 6 and the 1/6 will cancel, and you're just left with the cos of 6x, so that's how you know you've done it correctly. Then we're told a function, and we're told to find the equation of the tangent to the graph at the point where x is 2. So to get, obviously, to get the equation of a line, we need to know a point, and we need to know the slope. So we'll do the slope first. Slope is the derivative f prime of x, which will be equal to 6x squared minus 18x plus 5. And then we want f prime of 2. That'll be our slope m, which will be 6 times 2 squared minus 18 times 2 plus 5. And you can put that into your calculator, and what you'll get is minus 7. And then we also need to know a point. So what's f of 2? Well, f of 2 will be, again, it'll be 2 times 2 cubed minus 9 times 2 squared plus 5 times 2 minus 11. And when you do that, you get the y value is equal to minus 21. So that means the point is the x value is 2 and the y value is minus 21. So now the equation of a line, we have y equals mx plus c. We know that m is minus 7, so we know that y will be equal to minus 7x plus c, and we know this point. So we can say that minus 21 equals minus 7 times 2 plus c. That's just subbing in this point because we know this point's on the line. So that means that minus 21 equals minus 14 plus c. And then when we bring the minus 14 to the other side, that means that c is equal to minus 7. So therefore, the equation of the line is y equals minus 7x minus 7. Then we're told to find the x-coordinate of the point of inflection. So the point of inflection is where the second derivative is 0. So we know that the first derivative is this. So to find the second derivative, we just differentiate again. F double prime of x will be equal to 12x minus 18. We want that to be equal to 0 to find the point of inflection. So that means that x will be equal to 18 over 12 when you do that out. And then that's equal to just 1.5. Then we're given the graph of two curves, and basically we want to find when their derivatives are equal, the x values for which their derivatives are equal. So remember that derivative means slope. So what you should notice here is that the slope of the straight line shouldn't be too difficult to get. So if you get your ruler like this, remember that basically what we want is where on the curve p of x is the slope the same. So you could take your ruler, and we know this is completely parallel to the slope of the straight line, and we just want to find where is this tangent to the curve, because that's where the slopes will be equal. So you can see it's tangent roughly there. So if we figure out what the x value is there, roughly, it's about 6.7-ish, because this is 7 here, so this is about 6.7, 6.75 maybe. If you draw it more accurately, what you're supposed to get is 6.8, but as long as you show your workings correctly, it doesn't matter. So 6.8 is one of our values of x. The other value of x, you can see that we might be able to get a tangent down here. You can see we do get one just about here, roughly. And again, if you draw it properly, you'll probably get it closer than I do. But you can see that's just a bit bigger than 2, maybe 2.2 or 2.3. Let's say 2.2. And the marking scheme says 2.2, but again, as long as you show your workings with these two tangents, you should be good, and whatever answers you give. And obviously draw these dotted lines to show that you're getting the x value where the tangent is the same slope.